A probability distribution is not a distribution unless we conduct a number of trials. These trials are called the Bernoulli trials, and they are trials which I've covered in the last video. Each trial results in one of two possible outcomes, and they are labeled success or failure. The probability of random variable x, as we'll write big X, is equal to little x, which takes on the values of 0, 1, 2, all the way up to n. And often we can just write it as p to the x, little x. And now this takes on the formula which is written about here. And before I explain the binomial distribution, I assume that you all know the combination formula. And this represents the number of ways of getting successes from n number of trials. In other words, it calculates the number of paths that you can obtain. To really understand this combination formula, you really need to understand Pascal's triangle and how its expansion relates to the probabilities of a binomial distribution. These numbers here in the Pascal triangle are related to the combination numbers. For example, if you have a look at row 3, the combination numbers over here show us that if there are 3 trials, then if you have 0 successes, there's only one possible path for 0 successes. There are 3 possible paths for obtaining a 1 success, and then there's also 3 possible paths for containing 2 successes, and there's only one possible path in obtaining all 3 successes. And this can be really best represented by a tree diagram. So on this tree diagram, I'm going to show you how the combination formula relates to the tree diagram for 4 trials. In the first trial, we may get a success or failure. And this can be repeated for the second trial, the third trial, and the fourth trial. And as you can see, there's only one path which leads to success, success, success. And this can be shown in the 4th row, where only one combination of 4 trials and 4 successes occur. Now, to obtain 3 successes and 1 failure, we will have 4 combinations: success, 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 failure, success, success, failure, success, success, failure, success, success, and failure, success, success, success. And this will be represented by the number 4 in the Pascal triangle. And now you should be able to see that there are 6 combinations or 6 paths of the possibility of getting 2 successes and 2 failures. Now that we determine the number of paths are possible, we can start adding the probabilities by multiplying each outcome by its probability. In this case, the probability will just say the probability of success will be P, the probability of success will be P, whereas the probability of a failure, we'll call it a Q. And so to obtain 4 successes, we need to multiply P to the 4 times. So it'll be P to the 4. And to obtain 3 successes and 1 failure, we'll multiply and Q to the 1. And if I continue this, I should get, so from this, you can gather that I will have 1 P to the power of 4, plus I will have 4 P to the power of 3 and Q, and I will also have a 6 P squared Q squared, plus I will have 4 P Q power of 3 and plus 1 Q to the power of 4. And these are the different possible paths associated with their probabilities. Of course, these combinations refer to 4 trials. If we have 5, 6, or 7, we will have different number of paths. And that can be obtained using the Pascal's triangle. And the probability of success or failure must remain constant for this particular trial. Now, 4 things must adhere to make a random variable binomially distributed. Number 1, only 2 options are possible, success or failure. Number 2, there must be a fixed number of trials. Number 3, the trials must be independent. And number 4, the probability of success must remain constant. So the probability distribution of a particular variable is given by this formula where n over x is the combination formula which describes the number of pathways you can go through. P to the x is the probability of successes, and 1 minus p is the probability of failures. And if you found this video helpful and useful, then please take a moment to subscribe to my channel, and I'll see you in the next video.